my name is Muhammad Arifan and my metric number is 192514.
Hi, my name is Muhammad Azzi bin Solehan, metric number 193849.
My name is Amirul Mandini and my metric number is 193305. And thank you for Dr. Gida for giving me a chance to do this assignment.
So today I will do the video presentation about the dimension analysis. Firstly, I would thank to the Dr. Jila to give me an opportunity to do this video presentation. So next I will proceed to the dimension analysis. What is the dimensional analysis? Dimensional analysis is the powerful technique to test on a geometrical scale model to compare with the full scale prototype. So what the purpose of the dimensional analysis? There are two purposes of dimensional analysis. Firstly is we can obtain the scale so that prototype performance can be predicted from the model performance. Second, we can generate the non-dimensional parameter and reporting at the experimental result. So in the dimensional analysis, there are three similarities. First is geometric, second is kinematic, third is dynamic. So for geometric, it is about the shape, kinematic is about the velocity, and dynamic is about the force. All of these may be scaled with some constant scalar factor. Next, I will explain to you about the repeating variable method. In this, repeating variable method is properly predicts the functional relationship between the dimensional group. So there are 6 steps in the repeating variable. First is list the parameter in the problem and count their total number n. So next is list the primary dimension of each parameter. It is recommended in the exponent. So next, set the reduction j as the number of primary dimension. Calculate k, the expected number of pi's. Next is choose j repeating parameter. Next is construct the k pi's and manipulate as necessary. Next is write the final functional relationship and check your algebra. So after that, we can solve our problem by using the repeating variable. So proceed with the problem that related to the dimension analysis. For our group, we choose the train. So the question states that for temperature for prototype is 25 degrees Celsius. The density we get from the table properties of air at the 1 atm pressure. Dynamic viscosity for the density, and the velocity of the prototype that we can predict. We need to predict the velocity is 200 km per hour. So for the model, the temperature we do is 5 degrees Celsius, and we get the density for the model is 1.269 for the table, and dynamic viscosity we also get from the table, and the scale given is the model ratio to the prototype is 1/3. So to solve the problem, we need to know that the Reynolds number of the model and the prototype is same. So we can use the formula of rho VL over mu that same with the prototype. So now we need to solve the velocity of the model. So we just arrange the formula. We get this formula. So we substitute the value, the velocity, prototype, dynamic viscosity, density, and the ratio. We need to L over M. Lm over Lp is 1/3. Now we use Lp over Lm. So we need use 3. So at the last, we calculate and we get the velocity. So the velocity of module that we need to run is 430 and 0.97 km per hour. So that's all from me. Thank you.
Assalamualaikum and good day. Thank you Dr. Jila for giving me chance to do this assignment. Okay, what I understand about this topic, dimension analysis and modeling, when designer design something, they need to do experiment about their design. So in order to not waste their money and time, they not do the experiment in full scale of prototype. They do that experiment in model. For dimensional analysis and similarity, there are three primary purposes of dimensional analysis. First, to generate non-dimensional parameters that help in design of experiment. Second, to obtain scaling laws so that the prototype performance can be predicted from the model performance. Third, to predict sometimes the trend in the relationship between the parameters. Okay, next, there are three conditions for complete similarity. First, geometric similarities. Second, kinematic, and third is dynamic similarities. Okay, for geometric similarities, the model must be the same shape as the prototype. For kinematic, the velocity must be same also with the prototype at a certain point. And for dynamic similarities, this can be achieved when all forces in the prototype is all forces in the model is same with the prototype. Okay, next, to find the non-dimensional parameters, or we call pi, we need to use the method of repeating variables. Okay, for use this method, there are 6 steps that must be followed. Okay, first, list the parameters in the problem and count them. Let n be the total number. Second, list the primary dimensions of each of the n parameters. Third, set the reduction j as the number of primary dimensions. Calculate the expected number of pi, we denote as k. K equal to n minus j. For the next step, choose j as the repeating parameters. 5. Construct the k pi's and manipulate as necessary. For the last step, 6. Write the final functional relationship and check the algebra. Okay. For example, our group choose train. The objective of the question is to find the velocity of the model. Okay. Given here temperature for both prototype and model. Okay. For mu, density, and the dynamic viscosity, all of this can be obtained from table 1 at appendix. Okay. Given the scale is 1/3 model to prototype, okay, we use formula Reynolds number, which is rho VL over mu. Okay. After we rearrange all the formulas, we get this. Then plug in here. This is why we not change the unit from kilometer hour to meter per second SI unit. It's because when we plug in all the values, the unit will be cancelled out. So after we calculating all the values, and the final answer is 413.97 km/h. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Okay, I will explain about the dimensional analysis. Dimensional analysis is used to the geometrically scale model rather than on the full scale prototypes. This test can be save cost and time. There are 3 main purposes in this dimensional analysis. First is to generate the non-dimensional parameter. Second, to obtain law so that prototype performance can be predicted. And third is predict trend in the relationship between the parameter. There are 3 concepts of the dimensional analysis. First is dynamic similarity. Second is kinematic similarity, and third is geometrically similarity. First, I will explain you about the geometrically similarity. That is a model must have a same shape with the prototype. Next is kinematic similarity. Is a velocity at any point of the model must be proportional to the velocity flow of in the prototype. The last one is dynamic similarity. It is achieved when all the force in the model flow scale by constant vector to force of the prototype. Okay. There are several methods that we use to generate the non-dimensional parameter. The most popular and the useful formula, the simple method that we use to generate the non-dimensional parameter is a limiting variable. For example, the formula, the equation of Reynolds number, we combine the mu, rho and v and also the L, and we get the dimensional parameter. That's all for me. Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Robin Mandini, and next I will explain you about the question. Question asks we must to find the velocity of model that the application is we use a train. So from the question we can see and list the information that have in the question. The T is temperature for the prototype is 25 degrees Celsius, and we can see the other density and the dynamic viscosity from the table at the back of book fluid. We can get this one and these two, and also the velocity for the prototype of train, the actual train, we get 200 km/h, and this is a model. We give a 5 degree Celsius, and we see the table at the back of the book, and we get the density and the dynamic viscosity, and this is we want to find. Okay, the scale that given is 1/3, and we use a Reynolds number, formula for Reynolds number, because the Reynolds number is a equation that non-dimensionless. Okay, this is the equation for the Reynolds number, rho v L over mu, and we same at the prototype and the model, and we derive the formula, and so we just at the left we put the velocity of the model, and we just substitute this information in this equation, and then we get the answer. The velocity of our model is 413.97 km/h that we have to do at the lab for the model. And we also can use find the drag force coefficient, force drag, that we use the coefficient drag formula, because the coefficient drag formula is a dimensionless equation. That's all for me.